Hi there, my name is Ben Pierce, and today we're going to be taking a look at the 2018 Stack Overflow Developer Survey, exploring the data and using some machine learning techniques to see how well we can make predictions. Objectives. More specifically, we're going to be looking closely at one of the survey questions that pertains to job satisfaction and trying to predict which developers answered that they were extremely satisfied in their current role. Then, using those predictions, we're going to attempt to determine which factors influence developer job satisfaction. This is extremely important to me because I'm a director at an edutech firm by the name of Zello, and one of my key responsibilities is not just finding rockstar developers, but also making sure they're happy and want to stick around. As mentioned, we're using the 2018 Stack Overflow Developer Survey, as the 2019 results have not been posted yet. Although the technology industry changes fast, 2018 should still be recent enough to give us some useful insights. This particular survey includes 129 columns and roughly 100,000 survey responses. The survey questions include things you'd expect, such as salary and job benefits, but it also includes some very interesting data points, such as the number of monitors in use, exercise and sleep patterns, and developer thoughts on AI and ethics in technology. Some key challenges. In the real world, data sets are not perfect, and this one's no exception. A few of the key challenges. The first challenge is that most of the columns represent categorical data as opposed to numeric data. If you're currently thinking one-hot encoding, you're absolutely right. Another challenge is that the majority of the survey questions were optional, leading to many NA values that would either need to be imputed or dropped. Another challenge was that when all the one-hot encoding was completed, we were left with over 900 features, making overfitting an easy possibility if we're not careful. Finally, the target variable job satisfaction was itself optional. So right away, we've got around 30% of the responses that are not useful for training or testing purposes. The target variable. So let's explore the job satisfaction target variable a little more. For the purposes of this study, I'm only interested in developers who are extremely satisfied and will count those records as successes and the others as failures. As you can see in this table, almost 30% of the respondents did not answer this question. Target variables engineered. Here's the final data set I'm working with. First, you'll notice that I dropped 30% of the data because those are NA target variables and they're not useful for training or for testing. You'll also notice that I dropped moderately satisfied, slightly satisfied, neither satisfied nor dissatisfied, and slightly dissatisfied records. Why did I do this? Well, in my initial run-through of this exercise, I quickly found that the contrast between developers who were extremely satisfied and those that were moderately satisfied was very small, and the predictions I was making were very poor. My solution to this was to circle back and create a larger contrast by comparing extremely satisfied developers to those who were dissatisfied only. Feature engineering. In terms of feature engineering, I'll start with categorical variables, as it wasn't as simple as one-hot encoding them as they were. The survey had multi-select responses, and in the example we can see here, this particular developer chose that they work with JavaScript, Python, and CSS. However, this data was all stored in one field and concatenated by semicolons. Before I could one-hot encode the values, I needed to split the feature into its component parts, and we ended up with something that looks like the table here. Much easier to work with, but as you'd expect, this created a vast number of new features and added some more sparseness to the data. Some additional feature cleanup. Due to the number of features, I decided to drop any feature where 30% or more of respondents did not answer. One example here is ergonomic devices, which was only answered by 43% of the developers, and it would have been impossible to impute. Finally, numeric features such as salary were imputed as median and then scaled in the pipeline prior to training. This is an area where I feel I could have spent more time, as I could have tried imputing salary by country and job title or some other combination, but I kept it to median to keep things safe and simple. Feature selection. Initially, I trained my model with all features, but there were still over 500 of them and the model severely overfit things, as you might expect it to. To solve this, I decided to limit the features that were considered to only the top 20 as determined by the highest absolute correlation. In other words, the features with the highest or lowest correlation values to job satisfaction. Here are a few examples we were left with and their absolute correlations. Machine learning algorithms. Which machine learning algorithms did I try? Softmax regression, decision tree, and random forest. All of them perform fairly similar in terms of predictions, but random forest had the best performance of the three, so that's the algorithm I settled on. Please note, I used a series of random searches to ensure that I found the best hyperparameters for the random forest. Random forest performance. So what kind of performance did we get? Well, not as good as I had hoped for. I had hoped for at least 75% accuracy, but nothing I tried in feature selection, engineering, or hyperparameter tuning got me past 66.5%. As you can see, the resulting model has pretty good recall, which means there's relatively few false negatives being identified. However, this is counterbalanced by the somewhat poor precision, meaning there are quite a few false positives, as you can see in this confusion matrix. Overall, I would have liked to have seen a higher precision, but this was the best my model could do. Feature importance. So what did my random forest determine the best indicators were for extremely satisfied developers? Well, for starters, developers who contribute to open source projects seem to have the highest satisfaction. This could simply be indicative of developers who are passionate about technology. Additionally, developers who were passionate about the industry they're working in also scored themselves as having higher job satisfaction. In fact, according to this model, this was actually more important than salary, benefits, or vacation time. It seems that passion beats out the more tangible quantities. Another interesting feature that was flagged was whether or not a developer is new to their job, having started in the previous year. Developers who were still new in their role reported higher job satisfaction. Finally, it appears that the trend of remote work in technology is more than just a fad. Developers who work remotely or had the ability to work from home also reported higher job satisfaction. A highly correlated feature, which you'll see in here, is whether or not the company uses Slack, and that also lends credence to this. Further exploration. Some additional exploration I would have liked to have done, but didn't have the time. I was surprised that salary wasn't a bigger indicator of job satisfaction. Given more time, I'd like to explore this deeper and find out why. It could simply be that passion for technology and their company is much more important to developers than their salary. Aside from including country as a feature in my analysis, I also would have liked to have done a hierarchical analysis by country to see if some additional information could be gleaned from that. Perhaps developer values vary by country, and it's not something we could easily see with my model. Some additional data. This was the 2018 survey, but I could have spent some time munging other year survey results into this data set. The danger with this, however, is that technology and developer values change often, and bringing in previous year survey data could lead to an inaccurate model. Finally, there are other algorithms like XGBoost that I did not try, and it'd be interesting to see how well they work as predictors. Predicting developer job satisfaction with the 2018 Stack Overflow survey data was difficult due to the large number of categorical variables, the sparseness of the data due to most of the responses being optional, and the vast number of features available for me to use. If I had to summarize the key predictors for developer job satisfaction in 2018, I would summarize them by saying that passion in technology and one's industry are very important, as is the ability to work remotely, as is one's newness to the position. I'm excited to try my model on the 2019 survey results when they come out to see if any new trends have become visible in the past year. I appreciate your time, and I hope you learned a thing or two about developer job satisfaction.